All right, AP Calc, this is section 1.3, lesson 3, video number 4 to conclude this day's work. But I have 3 more equations. It's number 59, 61, and 63 that I want to solve with you guys. The first one gives you 2 tangent of t minus secant squared of t equals 0. So what are the strategies we have at our disposal? We could turn them all into sines and cosines. But if you look at secant squared as it relates to tangent, the identity that maps these two together is 1 plus tan squared equals secant squared. Which means if we replace secant squared of t with 1 plus tan squared of t, we get an expression that has nothing but only tangents in it. That'll be really helpful, especially if we have quadratic structure, because then we can do our W substitution, and it won't be as big of a taxation if we went back and did sines and cosines. We're gonna spin our tires in a bunch of different directions. So 2 tangent of t minus 1 minus tangent squared of t equals 0. I'm going to reorder this so that the squared term's up first. We can do our W substitution now. Remember, it's always the middle term in case you ever get kind of confused, or if the quadratic structure is like to the 4th squared or something little tougher than this. So I'm going to put a W here, a W here, and now it's starting to look a lot more like Math 1, which is good. I'm going to divide out a -1 from both sides. You're allowed to do that, just because whenever there's a coefficient out front that's negative, I don't know, in my brain it tends to mess up the factoring. This one is factorable. It's actually -1 times -1 is 1. Add them up, you get -2. So it actually comes out to be W minus 1 times W minus 1, which means you can call it W minus 1 squared. So it only gives you one solution for W. Add 1 to both sides and you get W equals 1. Okay? Which means tangent equals 1. And hopefully that jumps out at you like, hey, I remember that being a unit circle value back in the day. Well, not back in the day, just when you guys did pre-calculus. So tangent equals 1 when sine divided by cosine equals 1. So basically, when does sine equal cosine? At a 45-degree angle, which is pi over 4, or the 45-degree angle 180 degrees away. So at the 225 degrees, which is 5 pi over 4. And that's all she wrote for number 59. Let's check out number 61. Oh, this looks very familiar. We had a sine of 2t earlier. Common mistakes. Students will try to, quote, factor out a sine of t. They'll try to do this. But the question is, what is the sine of 2t divided by the sine of t? Because it doesn't equal the sine of t. It doesn't equal anything special, because it doesn't work the same way that sort of like our algebra thinking wants us to simplify this. Instead, you need to use those double angle formulas to get single t's so that you can actually work together with the sine of t. that formula says sine of 2t equals sine of t times cosine of t with the 2 out front. All right, it's in your upper right-hand corner of your formula sheet. Now we can take out a sine of 2t. Sine of t on the outside, 2 cosine of t on the inside, plus 1. This is the point at which you know that sine of t has to be 0, or 2 cosine of t plus 1 must be 0. All right. Then you got to ask yourself, where does sine equal 0? Well, on the unit circle, the signs are the y values, which means so you're going up nowhere on the unit circle. That's basically the x-axis values of 0, pi, 2 pi, 3 pi, 4 pi. If you're just stuck between 0 and 2 pi, and the way they write it is they put a bracket on the 0 to include 0, but they put a parenthesis on the 2 pi to exclude 2 pi. So don't include the 2 pi, because that's what the parenthesis says. Don't keep it in the final answer. For this part, you'd subtract 1 and divide by 2. So you get cosine of t is equal to negative 1/2, which again should be a familiar unit circle value. Cosines and sines are always equal in halves. But just remember, cosine is negative in quadrants 2 and 3, where the x value is negative. And cosine represents the adjacent side. So it's kind of like saying, hey, your adjacent side is the small half, the opposite side is the big root 3 over 2, which is the opposite of the reference angle. The reference angle, therefore, must be big instead of small. It must be 60 degrees instead of 30 degrees, which means you're talking about the pi over 3 values that exist in 2 and 3. So this is 2 pi over 3, and this is 4 pi over 3. So, my apologies. So those are your 2 answers, or your 4 answers, rather. All right, so I think you guys have seen very similar ones to these 2 in years past. And then I think number 63 as well, you guys have seen. If I have enough time, I'll try to work through it with 2 different strategies. Because I know sometimes maybe you don't use the strategy that I use in class, and then you're kind of like, well, what am I supposed to do from here? So the first thing I'm going to do, tangents sometimes go around in circles for a while. I'm going to turn everything into sines and cosines because I'm more comfortable with sines and cosines. So tan of 2x can be rewritten as sine of 2x divided by cosine of 2x. Tangent of x can be rewritten as sine of x divided by cosine of x. At this point, what I want to do is get rid of those fractions by cross-multiplying. So cosine times 2x, therefore, is equal to cosine of 2x times sine of x. And then I can subtract the right-hand side to the left-hand side. And just to save time, I'm going to say subtract, subtract. There it is. Now it's subtracted and equals 0. That's a nifty little move if you have a whiteboard here. Now, from what I can tell, man, this looks really familiar. Like, especially if I rewrite this as sine of 2x cosine of x. Let's see, where have I seen that before? It's the sum and difference formulas for sine. So it's the sine of u times cosine of v. But there's a minus here, which means it's got to be minus there. Oh my goodness. The entire left-hand side of the equation is sine of 2x minus x. What's 2x minus x? It's just x. Wow. Okay. Sine of x equals 0 at 0 and pi. That's the answer. I guess you have to have the presence of mind to make that to make that call. So what do you do if you don't make that call? Here's what you do. You've got sine of 2x times cosine of x minus cosine of 2x times sine of x. I would expect you guys to say, all right, I've got a double angle formula right here. I'm going to make the best use of it. 2 sine of x cosine of x times cosine of x minus, we held off when we did that proof here, and it's going to be a good idea to hold off again. Right? Not changing it into some other version of cosine of 2x. Oh yeah, because there's a sine that comes out. Sine of x comes out. So I divided it out. This is now 2 cosine squared of x. And it would make the most sense now to use the cosine squared version of cosine of 2x. I believe that was 2 cosine squared x minus 1 right there. Yeah, so then the sine of x equals 0. That's where we'd get the 0 and pi answers. This one equals 0 too, so it's 2 cosine squared of x minus plus 1. Huh, so those cancel. Well, 1 doesn't equal 0. So that's kind of like an equation that gave us some kind of gibberish. It doesn't mean the whole equation is now no solution. It just means that doesn't give us any viable options to include with the 0 to pi. So I guess there wasn't too much more work there. I would just encourage you guys to try to see if you can see sort of underlying structure that can be used to maybe simplify things for you. All right, one last thing, and it's important. Remember that whenever you do something like this to there, that you are potentially creating extraneous solutions. All right, I don't know if you remember hearing about those, but extraneous solutions are where you change the fundamental structure of something, specifically with asymptotes and domain issues. There's a domain issue here where cosine of x can't be 0 because it's on the bottom of a fraction. Cosine of x can't be 0. Also, cosine of 2x can't be 0. So if by chance you solve this and you started getting places where cosine equals 0 or cosine of 2x equals 0, you'd have to say, well, that doesn't work because it does not satisfy the original condition of the equation itself. So oftentimes you'll have to check your final answers by plugging it into the original equation. It usually happens when you take fractions and then rewrite them without fractions, or if you square both sides. All right. That's enough from me. I hope these videos are helpful, and yeah, I hope you're having some fun with this. Thanks for watching.